This is Timothy. Timothy is a loser. He spends a lot of his money on FIFA points. His favourite YouTube channel is PewDiePie. The one thing he has going for him is his girlfriend. Although he's a massive simp, no one can take away the fact that Timothy has a girlfriend. This is Andrew. He's hot. He was a stud. He looks like Jungkook from BTS. He only wears tight t-shirts and the Adidas superstars his mom bought him. Girls love Andrew. Uh-oh. Timothy's girlfriend seems to have noticed Andrew. Oh no. Timothy is sad. Little does he know, the same thing is happening in his tears, at a microscopic level. In his tears, there is a chemical called sodium chloride, or salt, for you simpler viewers. Salt is made up of two atoms, sodium and chlorine. Sodium has 11 protons and electrons, with 1 electron in its valence shell. Chlorine has 17 protons and electrons, with 7 electrons in its valence shell. Since chlorine has more positive protons, it tends to attract the negative electrons more than sodium. In fact, it attracts the electrons so much that it can actually take the electron from the sodium. This tendency to attract electrons is called electronegativity. Now the sodium has 1 less electron, which means it is a positively charged ion, or cation. We denote this by writing a little plus symbol here. The chlorine has 1 extra electron, making it a negatively charged ion, or anion. Now we have a positive ion and a negative ion next to each other, which means they are attracted, forming a special kind of bond called an ionic bond. I guess that means Timothy is now attracted to Andrew. I don't blame you, buddy. Look at that smile. This is Ben. He is just as hot as Andrew. He looks like Mark Twain from GOT7. The girls are confused. Who do they choose? Ben or Andrew?
¿Por qué no los dos?
The girls split themselves equally between Ben and Andrew, forming a non-polar covalent bond. A covalent bond occurs when 2 atoms share electrons with each other to get a full valence shell. When the 2 atoms both have the same electronegativity, the electrons that they share are balanced equally on both sides. This balance makes this particular bond a non-polar bond. This is Krish. He's alright looking. He's not a loser like Timothy, but he's no Jungkook either. When he rocks up, some of the girls taper off from Andrew. Mostly the curry girls, who know their parents are much more likely to approve of Krish. Andrew and Krish are forming a polar covalent bond. When 2 atoms in a covalent bond share electrons unequally, it causes an imbalance in the charges of the molecule. One side becomes more negatively charged and the other becomes relatively positive. These 2 opposite sides are referred to as poles, thus the name polar bond. These poles are the main cause for effects like dispersion forces, dipole-dipole bonding, and hydrogen bonding. If you don't remember what these are, watch the previous video here. 2 things that you need to remember is 1. These bonds are typically only used to describe forces between covalent molecules. That's not to say they don't exist in other molecules, but they don't really affect them as much. And 2. They are all more or less the same thing. When poles are formed in a molecule, they turn into tiny microscopic magnets, attracting each other, pulling the molecules closer together. We'll start with the least complicated. Dipole-dipole bonding occurs between polar covalent bonds. If you remember, there are 2 poles on polar covalent bonds, one slightly positive and one slightly negative. The slightly negative region of this molecule will attract the slightly positive region of this molecule, resulting in dipole-dipole bonding. Hydrogen bonding is essentially the same, but much stronger. This is because hydrogen is a very unique molecule with only one electron and one proton, giving it a very low electronegativity. When it is bonded with an atom that has a very high electronegativity, the poles formed are much stronger, turning it into a big Chungus magnet, which further results in very strong forces of attraction. There are 3 atoms that hydrogen can bond with to form hydrogen bonds: fluorine, oxygen, and nitrogen. HF bonds are the chungiest of hydrogen bonds because fluorine is very electronegative. HO bonds are the next chungiest, and HN bonds are the least chungo. Van der Waal dispersion forces are the most complicated, but bear with me, I'm sure I can think of some weird analogy for it. I got it. This is me. I am a grumpy ass person who doesn't like other people. Let's put a bunch of grumpy people like me onto 2 boats, boat A and boat B. First, let's have a look at boat A. The grumpies on this boat are going to be walking around randomly, until eventually one side will have more grumpies than the other. This means the negativity on this side of the boat is higher than this side, forming what we call temporary poles. They're called temporary because they were formed by the random movement of these grumpies and will not stay for long. Now let's look at boat B. Boat B sees all the grumpies gathering on that side of the boat. They are disgusted. They move away from that side of the boat until... Now they're all crowded on one side of their boat. This forms what we call induced poles, which are poles that were formed because of other grumpies on other boats. Now let's look at the bigger picture. We have boat A with its temporary poles and boat B with its induced poles. These positive and negative regions will attract each other, bringing the boats closer together. Now instead of grumpies, imagine electrons, and instead of boats, imagine molecules. These forces of attraction are called Van der Waal dispersion forces. If that cleared some stuff up for you, that's great. If you're now more confused than ever, don't worry. You're not alone. So is Timothy.